Can you hear me? Okay. Most important is the lady in the back, who I'm going to thank in advance for all her good work. So the focus of this presentation is precision soil fertility. I'm going to talk a little bit about concepts that we use, a little bit about how those are executed, and a little bit about the challenges we still face as we continue to advance the technology. Generally speaking, trying to do a better job with nutrient management, applying the right material at the right rate, in the right place, and at the right time are the main focus of our work. But I'm going to focus on two parts that are most important with the application of precision tools. Right rate and right place are probably the greater focus here. The concepts that we tend to follow fall into three categories. The first of these is a spatially variable nutrient application rate that is map driven. The map may come from a soil test information, and for some of our producers, the map may come from a yield map. The second situation is when the rate is driven by a sensor. And the third is our newest development in the United States, where we have a model-driven variable rate, and because the model is based in soil properties, the ultimate source of the information is a soil survey. So if I return to the first example where we have spatially variable nutrient application rates based on a map,
variable de nutrientes.
I'm going to give a couple examples
Les voy a dar
and how we
un par
use
de
them.
ejemplos
So we have a
y cómo
soil
los
test
utilizamos. Entonces tenemos
that
análisis de
is
suelo
spatially determined.
que está
We develop an application map from that for the nutrients, and then we execute or apply that map by applying nutrients. This is a simple system. In United States, typically a 2.5 acre or 1 hectare grid is very common. Subsamples within each of those grids are taken around the center of the grid, or sometimes they will zigzag across cells. So they'll cross one cell this way and then go back this way until they complete a column of grids. Technology looks something like this. The sampler, individual compartments for the soil, and a piece of equipment to move the sampler from place to place with a GPS guidance system. From this particular process, then a map may be generated of soil test phosphorus, in this case, values. Notice that these are not regular grids anymore. The data has been, we say, interpolated to try to bring some areas that were smaller together. It also provides some transition zones so that you can shift from one rate to another. And some of this field literally has 0 recommendation, and some has about as high as 130 kilograms of P2O5 per hectare. From that, we get a map of the recommended phosphate rates, because typically the controllers in the machines have limited step values, so you have to refine the application map to reflect the fact that you can't change in small enough increments, you have to change in larger increments. system, the GPS at the top of the machine. Actually a very old idea. This is a yield map of a field in south central Kentucky. And the yield
Aquí en el centro sur de Kentucky vemos en este mapa un rango de menos 5 hasta 12,5.
But they're grouped particularly into areas that are not very good and the areas that are generally better. If we look at the amount of phosphate removed in that maize crop, and we take into account that our recommendations really are in steps of about 34 kilograms P2O5 per hectare, we find that this field really only has 2 management zones, where the low yielding areas remove less and the high yielding areas remove more. And again, we return to an applicator where that map is loaded and the material is applied. Turning to the next concept, where we're going to use a sensor to drive the application. There is no map here. There is sensors that are going to make real-time decisions, changing the rate on the go. This is a research unit. We have a number of sensors here along the booms. Each sensor controls a set of nozzles for applying liquid nitrogen fertilizer. In this system, the sensor makes a reading, and the computer, with an algorithm, with a mathematical equation, triggers solenoid valves that then shift among the nozzles, where you could have no fertilizer, or you could have a high rate when all 3 nozzles are triggered at once for that one sensor. There's a number of machines working in this environment, like we have this Aapresid system, and Yara makes a system that's popular in Europe. Sensors are basically stupid. The reason for this is they never can tell you what a particular hybrid or a particular wheat variety looks like at maximum greenness or maximum biomass. So for that, you have to have small areas or a strip through the field where you've applied a lot of nitrogen so that the sensor will know this is what maximum color and maximum biomass look like. This is an example from an irrigated maize field where strips were applied to create high reference areas to keep the sensor referenced in terms of its high point. The algorithm may be a simple or a complex mathematical equation. This one is an example for corn that is V9 to V14 in age and size, where high rates are applied at a low sensor sufficiency index and no nitrogen is applied when the area of the field is equal to or close to that of the high nitrogen reference. This is an example in a commercial application where we have sensors located along the toolbar and we have a liquid nitrogen applicator behind the tractor. The last example is the model-driven example. The primary use for this has been to understand the differences in drainage in a field, and we use soil survey information, which we have a lot of in the United States. And then that is combined with very recent weather data, because many states in the United States have high density rain gauge setups across the grain production region. This is an example of a soil survey map. So the grower would provide this to the cloud or to a provider who's going to interpolate that map with the weather data. This is an example of a low resolution rainfall map for the month of June. The reason I choose June is because in most of these models, June precipitation is critical to determining the level of nitrogen loss in maize production. You can see that June precipitation ranged quite widely across the Corn Belt. These areas have much less rainfall, and these areas have much higher rainfall. The way the model works, we have here soil or plant nitrogen on the y-axis and time along the x-axis. Corn is planted sometime in April or early May. And as the corn grows, that's the projected modeled nitrogen uptake. This is mineralization of nitrogen from the soil organic matter. And one thing the grower must provide is organic matter data for the field at a minimum, and they prefer for areas of the field that match the soil survey map. In a normal season, all of this nitrogen will be available for corn to take up. But if we have a wet season, such as this year in Kentucky, we will lose nitrogen during this time period, and then the projected rate of side-dressed nitrogen is much higher for these wet years on wet soils than normal years on well-drained soils. But the modeling of this is all done by a third party. Typically, it's going to be, in the United States, it's going to be Monsanto with Climate Corporation, or it's going to be Pioneer DuPont. They offer it as a program called Encirca. They will develop a map of the second application for side-dress nitrogen rates. And the application can be at more than one time. But that means you need equipment like this because you may be going over very tall maize. So I'm going to close with a few of the challenges. The first one is that not all fields need grid soil sampling. The second one is that nutrient removal is often inferior to soil test-based approaches. That was demonstrated 20 years ago, but probably needs to be demonstrated again because of yield monitors and yield maps. You can have a sensor-driven nitrogen application when the biomass response is not due to nitrogen. You can have sensor-driven applications when the spatial scale of the nitrogen variability is not known, and you have your sensors arrayed on the boom inappropriately to capture that variation. And the last thing I'm going to say is, whose algorithm, whose mathematical equation are you going to use? This is a slide that overlaps with my presentation in the central arena. Again, when precision was cheap and potash was cheap, there still were very few fields where the value of that redistributed potash was worth doing precision soil grid sampling. That field that I showed you, that field 950, where I used a yield map to come up with a nutrient that was removed and therefore would be replaced. This is the soil test map for that field. I apologize, these values are in pp2m, which means you should divide them by 2 to get the standard ppm that you see in a soil test in Argentina. So the lowest levels are 35 ppm, and the highest levels approach 270 pp2m. So here's what the recommendation map should have looked like. 0 for the whole field. Should have been this for the whole field. And our recommendations are not as conservative as yours. So, nutrient removal is not made more intelligent by using a yield map to arrive at it. This is another excellent example where we have maize yield. Now this is in bushel, but every 15 bushels is 1 metric ton. So this is a huge response. Down here, we're at about 3 metric ton maize. And up here, we're at about 11 metric ton maize. We looked at NDVI values from a green seeker sensor at V6 and at V8. Looks great. The sensor is doing a great job with small corn predicting the yield at the end of the season. But this was a response to phosphorus, not nitrogen. Sensors are muy estúpido. When sensors cost a lot of money, you have to ask yourself how many sensors are really needed to capture the variation. In this example that I gave you earlier, this guy has 3 sensors here and he has 3 sensors there, but he averages the 3 sensors together and he's really only applying 1 rate on this side and 1 rate on that side. So is he capturing all the variation? He doesn't know. And the heck of it is, neither do we. Here's my example of algorithms. This is the research algorithm. In the United States, there's the retail algorithm. Now, in the United States, there is one very good legal reason to never go to 0. You never want to make a mistake on a producer's fields and cause maize to be nitrogen deficient. So there will never be from a retailer a recommendation of 0. Universities cannot be sued for their recommendations in court. But dealers can be sued in the United States. And in the United States, courts work. That's it. So I wish you a great season coming up. And I guess it's time for questions.
Bueno, la modalidad, me van levantando la mano, yo les acerco el micrófono y le van a traducir a John la pregunta en inglés. Así que, si hay preguntas... Perdón.
I can't hear you. Channel 2. Channel 2, and I still can't hear you. Now I hit it on. I turned it on. I still can't hear. It's on channel 2. Now I can. I found one, thanks to this gentleman here.
Bueno, le voy a hacer una pregunta para arrancar. ¿Qué nivel de adopción tienen las prácticas de aplicación variable de fósforo, potasio y nitrógeno en los productores de Kentucky hoy por hoy?
The variable rate adoption has been greater in the western part of the state, where the grain production is largest. The actual application goes on, but the whole approach to grid sampling has really changed in the last 5 years. The major thing has been people are going back to zones and soil sampling on zones to reduce the cost of that.
Sí, buenas tardes. Mi pregunta es, ¿cómo es la situación en Kentucky en cuanto a la adopción del análisis de suelo por parte de los productores? Porque acá en Argentina, digamos, estamos muy con la vanguardia de esto de la tecnología de la precisión, pero aún la adopción del análisis de suelos es muy baja. ¿Cómo es eso en Kentucky?
In Kentucky, I would say that 90% of grain fields are soil tested once every 2 to 4 years. So soil testing is widely accepted. We don't do enough plant analysis, but we do a lot of soil sampling.
John, desde tu experiencia, ¿cuál te parece la metodología más confiable para ajustar una dosis de nitrógeno en maíz?
As a researcher, and having looked at the literature, I do not yet feel comfortable recommending one technology as being more reliable than another. What I have recommended to producers, and I have clients both in the state and out of the state of Kentucky. The difference is in Kentucky I have to do it for free. I recommend they pick a technology and work with it long enough to become very comfortable with what it's doing or not doing by running some strip trials in their fields, on their farms, but to get comfortable with it. I believe that this works up to the point where the models have come out. The model-driven prescriptions are very new. And I don't have enough experience with those yet to recommend to any of my growers that they sign up for field scripts from Monsanto Climate Corp or Encirca from Pioneer DuPont. What I've recommended they do is pick a field that's a challenging field for them with their current nitrogen management system, give all the data they can into and pay the subscription fee just on that one field, and then start to gain experience with what model-driven nitrogen applications are going to mean. The model has the potential, in theory, to be as good, maybe a little better than sensors, but that's just an educated guess. I first would like my producers just to have the right technology to get nitrogen applied. In my state, only about 40% of maize producers have enough equipment to side dress nitrogen to all their maize. This means the other 60% have to apply all the nitrogen sometime before or near planting.
¿Cómo ve esta tecnología aplicada en Argentina? ¿Qué futuro le ve acá? ¿Cree que va a funcionar bien, que se va a adoptar bien, que los productores lo van a adoptar rápidamente o que va a costar un poco?
I have to be respectful of the fact that I've only been here about 7 times total. The first time was in 1988. So it's a span. So in my limited experience, I'm going to say that some of this technology will work in Argentina, but I'm not sure, given the pricing structure that you face, the taxes that you face, whether it can be applied cost effectively. The science, I think, will work. But taking the science into the field means you go through the marketplace. And it's not entirely clear to me how that's going to work. If we develop something new, particularly on nitrogen, and Argentina decides to really produce maize again, then we're going to have to get past what I call the dumb sensor generation. I can make sensors work for wheat, and we have a well-established algorithm that works for that. We raise winter wheat just like you do. But maize has been very difficult. And I strongly recommend if you can skip this generation of technology and move to something better, you might want to wait for that.
No es que me guste el micrófono, si me lo piden lo doy, pero bueno, hago una pregunta hasta que a alguno se le ocurra otra. Con el tema de los drones, ¿hay algo nuevo que pueda venir con eso?
Well, let's first try to get drone people to avoid. Let's first try to get drone people to avoid drones near helicopters and airplanes. We've already had several very serious near collisions in the Estados Unidos. So, drones themselves right now are a new toy. I don't think until we have a new sensor, a new camera, I don't think I can learn anything more from a drone. The only thing I can do with the drone is I can be more timely if I compare my results to people who are using, say, Landsat images or are scheduling airplane flyovers for picture capture. So some of our crop scouts are using drones because they can cover a lot of hectares per day with a drone. Otherwise, nada.
Bueno, tengo una pregunta más. ¿Cuál es tu visión sobre el producto que ofrece Monsanto hoy en Estados Unidos con Climate Corp? ¿Hay algo concreto ahí? ¿Hay algo que tenga valor o todavía no tiene suficiente valor según tu perspectiva?
I have an academic opinion, and because I operate 4 farms that are far away from me in Michigan, I have a commercial opinion. My academic opinion is that there may be something to offer in a very general way for nitrogen management, particularly for maize. But one of the other parts of the package is irrigation scheduling assistance. And I have found that, because the farms I have in Michigan have irrigation, I have found that to be quite valuable to me personally, as a commercial person. But much of the United States is still dryland agriculture. And I think there is a lot of indigenous knowledge because our grower age is indeed averages 58. So I resist the notion that the package that Climate Corp offers more than reassurance, let's say, if you're using the package on a field-based decision process. if you're willing to divide the field up into the soil map unit management zones, and if you're willing to make the equipment investment for these side-dressed later applications, particularly in maize, then perhaps it also has added value to you. But here's another problem I have. A lot of this technology in the United States has been developed for nitrogen, for maize. So in getting back to this earlier question, what do you see here for a soja grower in Argentina? Not a heck of a lot.
Una cortita. ¿Qué adopción tiene la aplicación variable de preemergentes en base a materia orgánica o textura? ¿Y qué perspectiva tiene o adivina que puede tener eso en el futuro? Herbicidas preemergentes en dosis variable.
There was a time period in the United States when I thought there would be a lot of adoption of that technology. We had some herbicides that were more active, and therefore you could reduce the rate based on both pH and organic matter. However, that was all swept away when glyphosate programs dominated maize and soja production. Now, however, because of resistance like Palmer amaranth, we are seeing the emergence of new residual, well, not new chemistries, but the emergence of more residual chemistry use from pre-emergence herbicides. So I predict there'll be some adoption, slow, of precision ag using soil properties, soil chemical properties, to manage these pre-emergence herbicides. But we're not even where we were before glyphosate came to dominate maize and soybean.
Bueno.
He's running out of questions.
¿Hay alguna pregunta más para John? ¿O vamos a ir cerrando el taller? Pues, te hago una última consulta que sale fuera de lo que has presentado, pero sé que trabajas con eso. ¿Quién provee información al productor, al farmer, para la toma de decisiones? ¿Son siempre los proveedores de insumos o existe la figura de consultores, estudios agronómicos que puedan proveer sin un interés en vender un insumo?
The surveys that have been done by my social science colleagues indicate that retail vendors of equipment and inputs are generally responsible for about 60 to 70% of where the producer goes with the first question. The next group they go to, an emerging group for us, are the private consultants. Private consultants are rarely utilized by the average farmer with 1,000 hectares or less. But we have seen the growth of larger farms, 2,000, 3,000, 4,000, 5,000 hectares or more. Many of those farmers either have their own staff agronomist or they hire a consultant. That'll be the second line. The third line is university extension in our system. And because university extension used to be the first and is now the third, the United States is disinvesting, actively reducing the amount of resources for grain crop extension in much of the United States. If you're not relevant, you have to find another way to spend those dollars when dollars are short.
Hola. Quería preguntarle cuál es la regla de decisión en Estados Unidos, en Kentucky, para aplicar fertilización variable. Si solamente se hace en lugares con limitaciones o en cualquier tipo de lotes de alta productividad.
Actually, the decision, in my opinion, rarely is based on, it's not based on a field. It's based on the decision of the owner-operator. If a field has proven to be very challenging, highly productive but very challenging to manage, a lot of those fields will go into more of a precision system. If the field is rented, particularly, we have rents that tend to run a little longer. We have a lot of rent that's 1 year. But we have a lot of acreage, a lot of area that's 3 years or 5-year contracts with adjustments. Okay. So if you have a challenging field that you don't have a lot of knowledge about, maybe the consultant within the large farm will make a decision. That field has to go into a precision program until we understand better how to manage it. In this time frame of low prices and high input cost, we are going to see field-by-field decisions on precision applications. I mean, application of precision technologies. You're either in the system, this field is in, this field is out. That's what we're going to see, because we cannot afford precision technologies on every hectare. Not now. And we're losing consultants too, or consultants are losing area of client area.
We are on time, John. Bueno, muchas gracias a todos por venir. John va a seguir por acá por el Congreso, así que tiene alguna consulta, lo ven. Y bueno, muchas gracias, John.